Here we go. We are on chapter 2, test review. Let me go over a couple of points that you should be focusing on for this test. Well, this chapter 2 is all about kinematics, and kinematics deals with some of these terms and definitions. Distance, you must know what is distance by definition. You must know what is displacement. Okay, displacement is the shortest distance from the starting point to the finishing point, and it's a vector quantity. Speed is the rate of change of distance. At what rate is distance changing? That is called speed. And velocity is the rate of change of displacement. So understand that velocity is displacement over time. Acceleration is the rate of change of velocity. Acceleration is the rate at which velocity changes. The units of distance, meters. This is meters per second, this is meters per second, and that's meters per second square. Now, speed, there are different kinds of speeds. We have the instantaneous speeds, which is the speed at that particular moment of time. And then we have the most important one is the average speed. So average speed of a journey is the total distance over total time. Now, if the distance is measured in kilometers and the total time is measured in hours, then the average speed is kilometers per hour. If the total distance is measured in miles and the total time is measured in hours, then it'll be miles per hour. If the total distance is measured in meters and the total time is measured in seconds, then it'll be meters per second. Okay. Similarly, what is average velocity? Average velocity is the total displacement over total time. Now, for a round trip, the displacement is going to be 0 because it goes and comes back. So total displacement can be 0 in some cases. In that case, the average velocity of a round trip is supposed to be 0. Acceleration is the rate at which velocity is going to change, and acceleration is Vf minus Vi over time. Now, this is the average acceleration over a period of time. So final velocity is Vf, initial velocity is Vi, and time is t. And you should know what is final velocity, what is initial velocity. All right, here we go. Let's do some math. Okay, here, mango. Cute. See? Want a light on here? There you go. Look up. Okay, let's do some physics work. Okay. Oh, hold on. Okay. So average acceleration is Vf minus Vi over time. Okay. You're covering up shit. Okay. So that is the acceleration. All right, time to go. Let's go. Bye-bye. All right, acceleration is Vf minus Vi over time, and it is from here that your first equation of motion pops up. The first equation of motion is Vf is equal to Vi plus At, and you must know. Those equations will be provided to you. Okay, and the other equations of motion, the displacement is going to be the average of the two velocities times time. And we have x is equal to Vit plus half At square. That's our third equation of motion, and Vf square is equal to Vi square plus 2Ax. All these are equations of motion to be used in case there is a uniform acceleration. Okay, this equation does not have displacement, this equation doesn't have acceleration, this one doesn't have final velocity, this one doesn't have time. So we have to pick the equation according to what is not given to you. And this is only applicable for accelerated motion. If there is no accelerated motion, then x is equal to vt is the only equation for non-accelerated motion. Okay. First of all, again, what is vi and what is vf can be a confusion for many. Just letting you know what is vi. Vi is the initial velocity, and what is considered as initial velocity is the velocity just after it starts the journey. Okay. Vf is the final velocity, which is the velocity just before it finishes the journey. So understand that it is not after it crashed somewhere, it is just before it finishes the journey. So if I'm going to throw something upward, when it is in my hand, that is not initial velocity. After it leaves my hand, that is the initial velocity. The same way, when it is about to reach my hand back again, that's the final velocity, not after it reaches my hand. Hope that's clear. Okay. And if it is a non-accelerated motion, then you can use this equation. Now, all these equations can be applied for horizontal motion as well as vertical motion, both ways. So this is the average acceleration, final velocity minus initial velocity over time. If something is moving at a constant velocity, there is no acceleration, because if it is moving at a constant velocity, Vf and Vi are supposed to be the same, and therefore Vf minus Vi is going to be 0. So acceleration is going to be 0. So acceleration is 0 for uniform velocity motion. Okay. Now, the quantities initial velocity, final velocity, displacement, acceleration, time, these are vector quantities. That means they can have a plus or minus. This can have plus or minus. This can have plus or minus. This can have plus or minus, but not this. This is always a positive thing. Time cannot be negative. Now, when is Vi considered positive? Is when something is moving to the right or to the east, you can take it as positive. When something is moving to the west or to the left, you can take it as negative. Same way, final velocity also can be positive or negative depending upon which way it's going. Displacement is the shortest distance from the starting point to the finishing point, and that can be a vector also, because if it finishes to this side, then it is positive displacement. If it finishes backward, that's a negative displacement. Acceleration can be positive if the velocity is increasing, and acceleration will be negative if the velocity is decreasing. So if the velocity final is smaller than the initial velocity, then acceleration will be negative. If the final velocity is bigger, so I can say if Vf is greater than Vi, then acceleration is positive. If Vf is smaller than Vi, automatically acceleration is going to be negative. And that is what we call deceleration. And time is always positive. So if you get answers for time, then if you have two answers, one a positive and a negative, you just knock off the negative and take the positive. That is the only time that is applicable. Okay. Now, can an object be moving in a positive direction and have a negative acceleration? Very much. Because if something is if a car is going to the right and applying brakes, then the velocity is going to slow down. So if the car is going to the right, so it's going faster, slower, slower, slower. So the velocity is reducing. That means the final velocity is smaller than the initial velocity. So automatically acceleration is negative. So the acceleration is backward. So the car is applying brakes. On the other hand, you can have velocity that is increasing that way. That means the initial velocity is small, final velocity is big, so it is an acceleration positive. Now, can something be moving backward and accelerating like this way? That's also possible. So acceleration in this case is this way. Acceleration in this case is that way. Now, if an object is moving like this, faster, faster, faster. So which velocity is bigger? This is bigger or this is bigger? So think of a number line. If you think of a number line, you will get an idea. So it is going slower, so minus 10, minus 20, minus 30, minus 40. So the velocity is decreasing. If the velocity is decreasing, the final velocity is smaller than the initial velocity. That means the acceleration is negative. So it is acceleration is this way. On the other hand, if I have this faster, slower, slower than that, slower than that, so it's like minus 30, minus 20, minus 10, minus 5. So now what is happening is the initial velocity here is much smaller, final velocity is bigger. So final velocity is big, initial velocity is small. So the final velocity is big and the initial velocity is small, acceleration is positive. So which means here the acceleration is positive and here the acceleration is negative. Okay, hope that is clear. Okay, so now let's look into other aspects. For horizontal, you will be mentioned about the direction of acceleration and so on. So then you can actually go with it. For vertical motion, especially when it is a free fall motion, not like a rocket, if it's a free fall motion, you can use acceleration due to gravity, which is always negative 9.8 meters per second squared. Just use that number straight away into problems. Okay, so that will be the acceleration from the time it leaves our hands. And suppose I toss something like that and it comes back to my hands. This is going to be the acceleration all the places. The reason is because Earth is pulling it down. Wherever the object is, Earth is the one which is pulling it down. Okay. So what is the acceleration on the top of the trajectory over here? When I throw something upwards, what is the acceleration on the top? It's going to be negative 9.80 because it is still in free fall. Even if momentarily stops, even if it stopped momentarily, it still is accelerating downward. That's why it's coming back. Now when an object is on the going up, the velocity is pointing upward, but the acceleration is pointing downward. When the velocity is going downward, when the object is going downward, velocity is pointing downward and acceleration is also pointing downward. Okay? Acceleration always points downward. So understand that main concept of this. Now, before we go to the equations of motion, let me give you the common questions relating displacement and time and average velocity and average speed and all that. So let me introduce that through a problem. So suppose you have someone going from one city to another city. Suppose somebody is going from city A to city B, and he's going that way at 40 miles per hour, and the distance from one city to the other city is 50 miles, and he's going at 40 miles per hour. So if he's going from here to here in 40 miles per hour, and then suppose he's going to rest over here for 50 minutes. If he's resting for 50 minutes and then he's going to come back, he's going to return back to city A with a speed of 50 miles per hour. So the journey starts from here, goes all the way here, and then waits for this much time and then comes back all the way here. Question is, what is the total time of trip from here back again here? So the total time of the trip is going to be adding all the times. So how long did it take to go from here to here? 50 miles in 40 miles per hour. So we're going to use this equation, x is equal to vt. So the time is going to be x over velocity or average speed. So time over here is going to be 50 over 40. I'm leaving in miles per hour because everything is given in miles. And that is going to be 1.25 hours. So that is 1.25 hours to go there. And then 50 minutes rest, which is how many hours? So you cannot keep minutes here when this is in hours. So we have to change 50 minutes to hours. A common mistake of changing 50 minutes to hours is by just putting a decimal there and saying 0.5 hours. But that is not 0.5 hours. So 50 minutes to change it to hours. 50 minutes is how many hours? Minutes to hours, the unit is going bigger by 60 times. Therefore, the number has to go smaller 60 times. So 50 over 60. Okay? So 50 over 60th of an hour. So that is going to be your time. You can actually find out how much it is in decimals and then work on it. So 50 divided by 60 is going to be 0.833 hours. So 0.833 hours repeated. Okay. And coming back, what is the time for coming back? He's traveling 50 miles at 50 miles per hour. So he exactly takes 1 hour. So 1 hour here, 1.25 hours here, and 0.833 hours resting there. So what is the total time of the trip? Is 1.25 plus 0.8333 plus 1. Okay. So when you add them up, it is 3.0, so which is equal to 3.083 repeating hours. You can just write 3.08 according to sig figs, 3.08 hours. Now, second question is, what is the average speed of the whole journey? The average speed of the whole journey, you know the definition of average speed, which is the total distance over total time. What is the total distance from city A to go there and to come back here? It's 50 one way and 50 the other way. So it's totally 100. And the time taken altogether is 3.08333 repeating. And so it's going to be 100 divided by 3.08333 repeating. And the answer is 32.4 miles per hour. You see how it is done. Especially this is the area that you can actually get stuck, because how to change 50 minutes to hours. Now 32.4 miles per hour. Third question is, what is average velocity? Average velocity is the total displacement for the entire journey divided by the time. And in this case, the total displacement is 0, and therefore 0 divided by any time is going to be 0. So you should say 0 miles per hour. And say the reason why, because the total displacement is 0. Hope this is clear. So this is something that you must be conscious about. You will get problems of this kind. This is non-accelerated motion. Because accelerated motion, we use the equations of motion. Okay, this is non-accelerated motion. And now applying these equations of motion. Before that, the graphs. So you should clearly have an idea of the graphs. What graph gives you what? Okay. What graphs gives you what? If you have a distance time graph, and if you have a line like this, it means it's not moving. If it's like this, it means uniform speed, and so on, right? Now, if it is a displacement time graph, or position time graph, then a line like this is not moving, and this is constant velocity, and this is increasing velocity, and this means a negative velocity going backward, and so on. And for a velocity time graph, if you have a line like this, it means constant velocity. horizontal line on a velocity graph, constant velocity, and this is constant acceleration. And this means constant deceleration. So understand what this, okay, the slope of this graph gives you speed. The slope of this graph gives you velocity. The slope of this one gets you acceleration. And the area of the velocity time graph is supposed to give you displacement. The area will give you displacement. Hope that's clear. So every stroke on a line, on a graph, has to make some sense, and make sure that you understand that. So horizontal motion, if there is no acceleration, you just plainly use that. Now if there is an acceleration, then you have to solve the problem according to the situation. Okay, and if it is an accelerated motion, you have to look into the problem as it is. So let's say, for example, I'm throwing a couple of examples. So if you have a bus or something like that that is moving at 10 meters per second, and all of a sudden it sees a cat and then has to apply brakes and stop. So the bus is applying brakes and stopping. So bus comes to a halt after traveling a distance of 20 meters. It's pretty strong. So 20 meters, the bus comes to a halt. So what, as soon as this is given to you, so the question is, how long did it take for it to come to a halt? Time taken for it to come to a halt. That's the question. So if the time is a question, what do you know? Initial velocity is 10, final velocity is 0, acceleration, there's no mention about it at all, displacement is 20. So what is an equation that connects this which does not have acceleration in the equation? And if you look at those equations, something that doesn't have the acceleration is that one. So we use that equation. So write down that equation. We have placed bi over 2 times time. Write this equation down and then substitute. X is 20 meters equal to bf 0, bi is 10 over 2 times time. The question is how much time. So it's 20 equals to 10 divided by 2 is 5 times time. So time is 4 seconds. So that's how we solve it. Don't forget this unit after you complete the solution. Don't forget the units here. You don't have to put the units while you are substituting numbers, but in the very end you should know what are you trying to find out. Time, in that case, the unit should be expressed properly in seconds. Okay, now if time was not the question here, but the acceleration was the question. If the acceleration was the question, then what you should do is, okay, acceleration is a question, initial velocity is 10, final velocity is 0, and displacement is 20. Now what is not given to you here is time, and therefore you have to go and pick that equation. Man, no, come. So you have to pick an equation without time. Bye. Come. Oh, okay. Sit there, okay? Sit down. It's fine. You're purring. Okay, go. Go. Okay. Don't knock this camera down. All right. Sit down. Sit down. Good. Okay, that's good. Okay. You want to study physics? All right. Looks like he's ready to solve problems. Let's solve problems here. Acceleration, velocity initial given to you, meters per second, final velocity is given to you, and x displacement is given to you. You need to find out an equation without time. So what is the equation here that is without time? The equation is this one. See, my cat is showing me the time equation. There it is. Alright, so the equation is right there. Vf square is equal to Vi square plus 2ax. Pick the equation and then after that substitute. Vf square is 0. Vi square is 10 and acceleration acceleration, so 2 times acceleration times displacement, which is 20. Now you solve it. 0 equals to 10 plus 40a. Subtract 40a from both sides. Minus 40a equals to 10. So a will be divided minus 40 on both sides. Divide by minus 40. So it will be 10 over minus 40, which is, hope everything's going right. Oh, 10 square. See, that's the reason why we write the equation down. My cat is distracting me. So when we write this equation down, we'll always be able to catch the mistakes that are taking place. So 10 square, so that's 100. And that will be negative 2.5 meters per second square. So that is a very strong acceleration for a bus because it has to stop before it hits a cat. Okay? So always go with the problem. You just have to find out what variables are given to you and which equation to pick. Right now we saw how this equation is picked up. Now we saw how this equation is picked up. Now, if there is another question where there is another question where, let's say, come to the bus again. The bus is moving at 10 meters per second and it applies brakes at the rate of it is applying the brakes, all right. So after a time of 3 seconds, if it is applying the brakes and accelerating at a rate of minus 2 meters per second square, what is the final velocity? So here initial velocity is given, final velocity is required, acceleration is given, time is given. So here what is not given to you is the displacement. So what you have to do is pick an equation where displacement is not given, and that is this. And so we have Vf is equals to Vi plus At, and then apply, substitute. Vf question, Vi is 10 plus minus 2 times 3. So you get 10 minus 6. So Vf is equal to 4 meters per second. So you can see how this equation is now being used. So it all depends on how you pick the right equation to solve the problems. And to show you how the other equations can be applied, let's say again the bus is going at 10 meters per second. I'm taking the same example. The bus is going at 10 meters per second. It is accelerating at minus 2 meters per second square. How fast is it going after it has moved a displacement of 10 meters? So what is the final velocity? Oh no. Oh no. How long does it take to move 10 meters? So question is t. How long does it take to go 10 meters? So which equation are we going to use here? So final velocity is not given to you, but everything else is given to you. So you pick this equation, x is equals to VIT plus half a t squared. Then you can actually work it out from here. So displacement is 10, initial velocity times time, so 10t plus half acceleration, which is going to be half of minus 2 times t squared. Now this equation turns into a quadratic equation. This becomes a quadratic equation in t. So if you simplify this becomes minus t squared. So bringing everything to one side, it will be t squared plus 10t, no, t squared minus 10t, because this goes up this way, and minus 10t plus 10 equal to 0. So you have to solve this quadratic equation, and you'll get the solutions for time, and from there we can actually figure out how long it takes for the bus to go from here to here. So I'm just showing an example of how this can be used. If you want to solve the quadratic equation, you can either use a solver or you can use the quadratic formula. The quadratic formula is the quadratic formula for ax squared is plus bx plus c equal to 0. That's a quadratic equation. X can be solved by minus b plus or minus root of b squared minus 4ac over 2a. That's your equation. And the equation that we just saw is t squared minus 10t. So t squared minus 10t. Checking if that equation is correct. T squared minus 10t plus 10. Okay. T squared minus 10t plus 10 equal to 0. So if you look at this, there is no coefficient for t squared. So a is 1, b is minus 10, c is plus 10. Okay, so substitute now into this. If you substitute into that, t is going to be minus b. B is already negative 10, so it will be 10 plus or minus root of b squared, that is negative 10 squared, that is 100, minus 4 times a times c, 4 times this, minus 40. 4 times 10 times 1 is 40 over 2a, 2 times 1, 2. Now it's a matter of simplification. 10 plus or minus root of 60 over 2. And then you simplify from there. So root of 60 is 7 point something. So you have 10 plus 7 point something divided by 2, and 10 minus 7 point something divided by 2. So both answers are possible in this case. Let me go back to this problem here. Let me see why both are possible. Displacement is 10 meters. Initial velocity is 10. Acceleration is negative 2. So negative t squared times time. So there are 2 times when it's going to be having at the same displacement. Okay. The reason why this is happening, so you have 2 times when this can happen, and the reason behind it is that this bus is actually applying brakes, or acceleration is negative, so it is going to cross here at the first time, and then it will keep going, stop, and then come back to the same spot after the next time. So both times are possible. That is why you're getting both positive answers. Okay. Now, if the problem involves up and down movement, like instead of horizontal movements like the car and bus, if it's an up and down movement, how do you tackle it? So if I throw something upward at a velocity, suppose I'll say, all right, I don't know what velocity I'm throwing it. What will happen to it is it'll go and come back. So if I ask you this, suppose the whole thing returns after a time of 2 seconds. How fast should I throw it up? How fast should I have thrown this up in order to make it return after 2 seconds? So the question is asking you for what is the initial velocity with which you're throwing this thing up. So initial velocity is what? Final velocity, no clue. Time is 2 seconds. Acceleration is negative 9.80. 2.00. And displacement is the starting point to the finishing point, which is 0. And then you can solve for this. So what equation are you going to use here? We have no idea about final velocity, so we pick the equation without final velocity, which is x is equal to vit plus half at square. X is 0 equals to vit. We don't know vi, so vi times time is 2 seconds, and then plus half of negative 9.8 is always 4.9, and then times 2 square. So we have substituted. After this, write it again. 2vi minus 4.9 times 4 is 19.6. Now add 19.6 to both sides. These are all mathematical steps that you're supposed to follow properly. And then we have vi. So vi, divide both sides by 2, so you get 9.8 meters per second. That's your initial velocity with which you should throw something in order for it to come back after 2 seconds. Hope that is clear. So likewise, all such questions can be answered with the same equations of motion. Another example, if I'm going to throw something up with a speed of 20 meters per second, how high does it go? How high does it go before returning? Of course it has to come back. So how high does it go? Now the question is focused on between these 2 points. So the initial point is here, final point is at the highest point. So what information do you know about this? What information do you know about this? You can pause this video right now and then after that solve it and see how the solution is. Is it in agreement with what you're thinking about? Okay, so initial velocity here is positive 20 because I threw it upward. Final velocity over here, do you have an idea what's the final velocity when it's turning around? It is going to be 0 because it's going slower and slower and finally stopping there and coming back. Displacement from here to here, that is something which we don't know and we want to know that. And acceleration is negative 9.80 always. And time is not asked in the problem. So how high does it go is the question. Therefore we have to pick an equation which does not have time, which is vf square is equal to vi square plus 2ax. Vf square is 0 equal to vi square is 20 square plus 2 times negative 9.8 times x. So it becomes 0 equal to 400 minus 19.6x. Add 19.6x to both sides. That will give you 400. X is equals to 400 over 19.6, which is a little more than 20 meters. Okay, say 21 meters something. So that is how we find out how high it went. And if you want to know what time it took for it to reach the highest peak, then the question is this. So we have to just assume that we don't know the displacement. So let's work that out. If the question was the time, so you throw something up at 20 meters per second and it goes up and turns around. And so let's see what is given. Vi is 20. Vf on the top is 0. Displacement is not our question. Acceleration is negative 9.80 meters per second square. As long as 3 things are already there, you should be able to solve for anything. So time is equal to what? What equation are you going to use here? Something that doesn't have displacement, and it is the first equation. Vf is equal to vi plus at. Substitute. 0 equals to 20 plus negative 9.8 times 10. So 0 equals to 20 minus 9.8 t. This is the whole expression. So add this whole thing to both sides. So it becomes 9.8 t equals to 20. So t is 20 over 9.8 in seconds. Okay, you have to simplify this and get the answer something like 2 point something seconds. 2.1 seconds. So this is pretty much how you do all the problems with different equations of motion and how to tackle these kind of questions. Okay, so hopefully this should help you prepare for your test, and make sure you do your problems clearly, showing a little diagram, showing all the data, pick the right equation, substitute, don't make a mistake in the algebraic part, and get the answer. All right, good luck with your preparation.